You've learned how to solve systems of equations using graphing, substitution, and elimination. When we looked at elimination, we noticed that we needed to have coefficients that were the opposite so we could eliminate one of the variables. Sometimes, and in most cases in the world, we don't automatically have a system with coefficients that are the opposite, so we have to manipulate the system so that we can use elimination to solve. So let's look at a problem in context to help us. A landscape architect purchased 5 century agave and 3 cholla cacti for $150 for a project. This is the century cactus and this is the cholla cactus. For a different project, the architect purchased 2 century agave and 4 cholla cacti for $102. The landscape architect would like to use both plants again, but lost the receipt. In order to plan an estimate for her new clients, she needs to find the per plant cost. Write a system of equations to help her. So let's start by defining our variables. So if we let x equal cost of century agave and y equal cost of cholla. For that first project, she bought 5 century plus 3 cholla and spent a total of $150. And for the other project, she bought 2 century agave and 4 cholla cacti, and the total cost was $102. So if you notice in this system of equations, we don't have any coefficients that are the opposite. So let's see how we solve that. So what we want to do is choose one of the variables to eliminate. So in this case, I'm going to choose to eliminate x. So what I want to have here are 2 variables or 2 coefficients that are the opposite. So in order to make that happen, I am going to multiply the first equation by -2 and the second equation by +5. When I do that, I'm going to have the coefficients of x will be -10 and +10. So we have -10x minus 6y is equal to -300. And in the second equation, we have 10x plus 20y is equal to 510. So now we can just add the equations together. So we get 0x plus 14y is equal to 210. And when we divide both sides, notice that 0x, that just cancels out, and so we have divide both sides by 14, and y is equal to 15. So now we know the cost of the cholla was $15. So in order to find the cost of the century, we will substitute 15 back into one of our previous equations. And you can also use the equations that you have manipulated if that works better. But in this case, it looks like we'll have to deal with bigger numbers, so it might be easier to put it back into the second equation. So if we have 2x plus 4 times 15 is equal to 102, and so that looks like we'll have 60 here, and we can subtract 60 from both sides, and we get 2x is equal to 42. We divide by 2, so x is equal to 21. So the cost of the century agave was $21. sometimes you'll encounter systems where you don't have to multiply both equations. So it's really good to look back and see the big picture before you just start using a method. So let's actually analyze this. In this case, if I eliminated x, I would have to multiply the top equation by 2 or -2, and the bottom equation by 5 or -5. But if I look at y, and eliminating y, it looks like I will only have to multiply the second equation by -2 in order to get a -6 here. Recall that 6 and -6 are opposites. And the numerical factor of a term is called the coefficient. So that's the number being multiplied by the variable. So let's go ahead and multiply the second equation by -2. And that will give us, and I'm actually going to rewrite the first equation just so I don't make any mistakes. And then I have -4x minus 6y is equal to +10. And when I add these together, I get x is equal to 2. And then I can substitute 2 back into either equation to help me solve. So let's go ahead and do it in the second one. So we have 2 times 2 plus 3y is equal to -5. So we have 4 plus 3y is equal to -5. We're going to use our properties of equality, our subtraction property of equality. So we have 3y is equal to -9, and divide both sides by 3, and y is equal to -3. So our solution, or the point of intersection where the two lines intersect, is 2, -3. So now it's your turn. I'd like you to try 2 different student problems. The first student problem looks like this: 6x minus 2y is equal to 10, and 3x minus 7y is equal to -19. And the second student problem is 5x minus 3y is equal to 6, and 2x plus 5y is equal to -10.